As with Ming, today we talk about rule for sums for differentiation. From our previous video, we noticed that for y equal to mx plus c, we get the derivative with respect to x as m. That is, it seems like if we want to take the derivative of a sum, we can take the derivative terms by term. If I want to divide the x, in this case, it's the same as d of m x O by with respect to x and the derivative of c with respect to x. So the first term here is m. The second term is 0. Therefore, I get the answer m. In fact, this is actually can be proven to be true. And higher level student may want to prove that if you have y equal to a sum of two functions, let's say f of x and g of x, then the derivative of this sum is just f dash plus g dash. In another word, that is the derivative of a sum is just the sum of the derivatives. And in fact, this particular rule will also work if you have f of x minus g of x. And in this case, the derivative will become derivative of f of x minus the derivative of g of x. And you will see that this is a very useful rule to have. Now, for example, we have this. That is, take the derivative of x squared plus 2 of x plus 1 dx. Basically, this notation means that if y is equal to x squared plus 2x plus 1, then what is dy dx? Basically, that's the question. The derivative of the first term, that is 2x, derivative of the second term, 2, derivative of the third term, 0. So I have 2x plus 2. This x times x to the power of half minus 3 times x to the power of negative 1 dx. And this is the same as d of the derivative of x to the power of, using index law, 3/2 minus 3 times x to the power of negative 1 dx. All right. So then we can take the derivative term by term. So the first one is the index becomes the coefficient, 3/2 x to the power. The new index is 3/2 minus 1 minus, then the second the derivative of the second term, 3. The index is negative 1 becomes the coefficient, part of the coefficient, and then x to the power of negative 1 minus 1. So we have 3/2 x to the power of 3/2 minus 1 is half. Minus minus become plus x to the power of negative 2. So it's 3/2 square root of x plus 3 over x squared. And y dash, the derivative of 3 is 0. 2x is 2. The derivative of 7x to the power 4 is 7 times the power comes down to become part of the coefficient, and x to the power of 4 minus 1. So the answer to this is 2 plus 28 x to the power of 3, or x cubed. That's it. 3 to the power of x to the power of negative 1 minus 4 x to the power of negative 2 plus x to the power of negative 3. And then y dash, use the correct notation, y dash in this case is 3 times negative 1, x to the power of negative 1 minus 1 minus 4 times negative 2, x to the power of negative 2 minus 1 plus times negative 3 as the new coefficient. Use the bracket for clarity, negative 3 minus 1. So y dash in this case is negative 3 x to the power of negative 2, and negative become positive, plus 8 x to the power of negative 3, and then minus 3 x to the power of negative 4. So this can be rewritten as y dash negative 3 over x squared plus 8 over x cubed, and then minus 3 over x to the power of 4. And that's it. And here's the last question here. And this one, the derivative doesn't always have to be with respect to x. We can also use the derivative of v, in this case the volume, with respect to r. So what is the change in the volume if there is a small increase in the radius? So for example, this dv over dr, that is, you let r to be the variable and everything else is treated as constant. So the answer to this will be 2 pi rh, because the pi and h in this case are treated as constant. So the answer is 2 pi rh. The next one is dv dh, that is, how much is the volume changes with a small change in the height. So in this case, you will have to treat pi r square as a constant, and dv dh in this case will be pi r square, because with respect to h, then the answer is just pi r square. Very good. dH, that is, how much is the volume changing when there is a small change in height. So the answer here is you would need to treat the 3w as a constant. So the VDH in this particular case is just going to be 3w. And B, the VDW, and that is you treating 3 and h as constant and w as the variable. Right, w here is the variable. So the answer to that will be just 3h. Thank you very much.